Alrighty, folks. So we're going to start on our next unit, which is on sequences and series. So I'm going to give a little bit of the background about what a sequence and a series is, and then we're going to dive into a couple particular types of sequences. So we'll talk about that in just a second here. So first of all a sequence is just a set of numbers in a specific order. So it's like a list of numbers. So down at the bottom of the screen, I have an example of a sequence here, the way that we'd write it out in general. So we use these variables A to stand for the numbers in that list. And the little subscripts tell you which number in the list you are. So A with the little subscript 1 means term number 1, and then A2 is term number 2, term 3, and so on. And then AN, this nth term is what we would call that. That's just the general term, kind of like our rule or our equation we'll be coming up with in a little bit to talk about what that term is. So that could be any term in the list. So it's just a much more general one. But the term number is just the subscript, and the A would be the variable placeholder for what the term is. And then the terms, as I've been talking about this, those are the actual numbers or expressions in the sequence. So the terms are the actual numbers that you are listing. So they can actually be expressions, though. They don't just have to be numerical. They could be variables in there as well. So it just depends on what the data is. So we can have sequences that are generated with all sorts of different rules. But there's a specific order involved to them, but how you get from one term to the next differs depending on what kind of sequence you have. So maybe some of you have heard of the Fibonacci sequence. That's a very unique set of numbers. It's a list. It's a very ordered thing, but they're not necessarily always going to be in that particular order. There's lots of different ways you can get from one number to the next. So the type of sequence we're going to talk about today is called arithmetic. So arithmetic is a very special type of sequence where the difference between terms, so successive means right next to each other, is a constant, like it's always the same. So what we call that is the common difference. So the difference between the terms as we go from one term to the next is always the same. And because they're super creative, we call that D for difference. So what you go up by each time is always the same. It's a constant. So what does that remind you of, this idea of constant change? That is a linear situation. So if you actually graph the term number and the value of the term and you plotted those points in a scatter plot, they would form a linear relationship. You would be going up by the same amount each time. So let's take a look at this example down at the bottom. This is a great example of something that's arithmetic. So arithmetic means you're going by a common difference between each term. So as we go from one term to the next in this sequence, what is the pattern? What are we going up by? Well, each one of these, we're going up by 6. Now, some people figure that out by counting up. So this idea of going, how much do I need to go up from -10 to get to -4? Or how much do I go up from -4 to 2, and so on. But another way to do it is you can take any term and subtract the term in front of it. Like for me, when I looked at it, I looked at these two terms and I said, oh, what's 8 minus 2? 6. Cool, that's what we're going up by. So the reason we call it a common difference, you're looking at how far apart the terms are, you can subtract to figure that out as well. And it's really important that it's common. It has to be the same thing between every pair of terms. Otherwise, it wouldn't be an arithmetic sequence. It could be some other type. Okay, now, how would you get to the next term in the sequence then? Well, just continue the pattern. You would add 6 again. Not too difficult, so we could keep going. Here's something interesting, though. How would you go backwards in the sequence then? If I'm at -10, how would I find the preceding term, the term in front of it? Well, if you're adding 6 to go forward, you're going to have to subtract 6 to go backward. So in this linear situation, we can go in either direction. If it's adding to go one direction, it's going to be subtracting to go the other way. So we think about that pattern continuing infinitely in both directions. Okay, so let's practice that really quick before we get into kind of our next phase of this. So I'm giving you an arithmetic sequence. So I'm telling you that it's arithmetic. Later on down the line, though, when we do other types of sequences, you're going to have to be able to determine if it is, in fact, arithmetic or not. So we have to kind of keep in the habit of always figuring out what this D value is. This one's a little trickier. People have more trouble counting up in this situation because they're decimals. So remember, again, another way to think of figuring out the common difference is taking any term and subtracting the term in front of it. So you could do that with the 0.2 and the -1, or the -1 and the -2.2. You can do it either way, and you may need a calculator just to help you out with this a little bit. But either way, you're going to get a 1.2 for your common difference. So be aware, you can always subtract if you can't count up and that's too difficult, especially with some of them that have variables. You'd almost have to do that because it's not going to be a numerical answer anyway. All right, so find the next 4 terms. So what you know is A1, you have term 2, and you have term 3. What I'm asking you for is the next 4 terms in that pattern. So you're looking for A4, A5, A6, and A7. Well, how are you going to figure them out? Well, just use your common difference. So we add 1.2 each time to move forward. So we'd have 1.4, and then 2.6, 3.8, and then a 5.0, et cetera, et cetera. It could continue forever. So this idea of a sequence, how do we find the next number, should be okay. Now, but what if I ask you for like the 100th term? Well, gosh, I don't want to keep adding 1.2 until I get all the way to the 100th term, having to show all of them. That would be a drag. I guess I kind of call that the brute force method. It'll work. You can get there, but I bet there's a better way. How can we just kind of skip ahead in the sequence and get to a particular term that we want? So I'm going to start us off with a little bit easier set of data to try to come up with a rule for this, like a shortcut. We could have done it with the last example, but I feel like it'll be easier with whole numbers. So we're going to do some integer values for this one. I'm going to have you write a sequence for me, and then we're going to see if we can look at the patterns in this specific example to come up with a much more general sort of formula, I guess you could call it, or relationship that would help us find a term down the line without having to do all the ones in between. All right, so the first 5 terms in the sequence that I'm starting with, it says the sequence starts with a -6, so A1 is -6, not the steak sauce. Think about that for a second. And then how do I get to the next one? Common difference of 5. Well, I'm going to add 5 each time then. So -1, and then 4, and then 9, and then 14, et cetera, et cetera. So I have the first 5 terms. I put together a little organizational structure for us to kind of look for these patterns. So if you can go ahead and get the term names and the answers in there, those are things we know already. We know A1 is -6. A2 is -1, and so on. So the term number is where you are on the list, 1, 2, 3, 4, 5. The name of the term would be A1, then A2, A3. The answers we know because we figured it out. Now what we're shooting for is what I boxed down here at the bottom. I want eventually to come up with the rule for the nth term. So in general, if I wanted to figure out A1000 or A100 or A52, I could do that without having to have the term in front of it, because that's the problem with listing all of them. You'd have to have every single term to be able to get the next one, and that just takes too long. All right, so let's talk about what we do. For the first term, there's no real calculation, right? The first term, they give it to you. It's -6, so you have that information. There's no calculation to be done. It's just the number -6. It is literally just the A1. There's nothing to do to generate that. It's just that number. Okay, but then how did you guys find the A2? How do we find the next number in the sequence? Well, we took our -6 and we added the 5 to it, right? That gave us the -1. So in general terms then, that means we took our A1 and we added 5. And what does the 5 represent? Well, that's the common difference, right? That's the common difference that we are having in this relationship. So I'm just going to call that D. I added D to it. Okay, now how did you find A3? Well, what we did, because we were just going consecutive terms, is we took the A2 answer, -1, and we added 5 to it, which is fantastic if you have the term in front of it. But what I'm saying is, what if we don't? What if we want to go just from the beginning and jump right to the end without having to fill in the numbers in between? How could we do that going back to the first term? So I don't want you to think about going back and adding 5 to A2. I want you to think about going back to this A1, this -6 that we started with, and what would you add to that? Well, how many 5s would you need to add? Well, you had to add 5 to get to A2, and then you had to have another 5 to get to A3. So all together, you're really adding 2 5s, aren't you? So think of that, arithmetic checks out. So 2 times 5 is 10 plus -6. Yep, that would be 4. So it's really A1 plus 2 of those differences. So I guess I could have said 1 difference back there, right? I only needed to add 1. Well, let's keep this pattern going, see what happens. To get to the 4th term, again, I want you to go back and use term 1, because we can't we can't use the term in front of it if we're trying to jump ahead. How many common differences would we need to add? Well, it would have to be 3 now, right? We need another 1. And check out that arithmetic. 15 minus 6, that's good. So that's A1 plus 3 differences. Now, how would I get to A5? Well, I would need to do the same thing, but now I need 4 differences. So 4 of those 5s. So that would be 14. So A1 plus 4 of those common differences. Now I'm going to go back and I'm going to fill this in and see if you think this is okay. I could have just said that too, right, to finish off the pattern. I could have said I didn't need any I don't need any differences, 0 of them. Well, no, of course you don't need any differences. It's the first term. You haven't had to move anywhere yet. So follow the pattern. I bet you could predict what we need to find for A6 then. We need A1 plus 5 common differences, And on it goes. So let's see if we can come up with the rule for AN then. Looks like we always start with the first term no matter what, and we're always going to have a certain number of common differences. The question is, how many common differences do we need? All right, well, let's see what's happening. For the fifth term, I needed 4 differences. For the fourth term, I needed 3. For the third term, I needed 2. So how does the number of differences relate to the term number? It's always 1 less. So how do I say 1 less than n? It would be n minus 1. So that's how we can generate that. Why is it n minus 1? Why isn't it just n? Well, you don't need a difference for that first term. It's 0 of them. So I just need one for each subsequent term after that. So go back to my example. If I was asking you to find then that A100, how many common differences would you need? Well, you would need 99 of them then, right? N minus 1. I don't need to add it on for the first one. I can add on all 99 of them though at once, and I don't have to write all of those 99 terms to figure out what it would be. So it's great. All right, so here's our formula. It's a relationship. A lot of people think of it just as common sense because it is. So if you're doing common sense kind of arithmetic stuff, you would probably be able to come up with this formula yourself. All right, so the nth term, that's the AN. The first term is your A1. And then the number of terms, how many terms do you have total in that series and then or sequence? And then D, that common difference, that's your slope. That's what you're going up by each time. So if you're thinking of this as a linear equation, the AN is like your Y, and the N is your variable X. It's the term number. It's what the answer depends on. And the slope is what it's changing by each time. So it's very much a linear equation if you graph that relationship. So we're just going to walk through and sort of to get confident and comfortable with what this relationship is with a few different scenarios. Okay, so say you want to find the 33rd term in a sequence. That's arithmetic, so they're telling you that. And we want to jump ahead. So I told you it was arithmetic, but let's just double check. How many terms would I have to give you if you didn't know it was arithmetic and you had to check? If I just gave you 2 terms, it really wouldn't be enough because there'd be a lot of different ways maybe you could get from one term to the next. Excuse me. So we really should check more than one pair just to make sure it keeps doing the same pattern that we think it would. So first thing I'm going to do is figure out what is this common difference. So it looks like we're going up by 7 each time. And again, remember, you can count up, and that's cool. Otherwise, you can subtract, right? 13 minus 6, 6 minus negative 1. You can count up how many do you need to go from -8 to negative, however that works for you, but make sure you can come up with that common difference. All right, so we want the 33rd term. That means n is 33. That means visualize in your head like 33 people standing in a line, and you're looking for that 33rd person. So there's 33 things. That's what the 33rd term would mean. So in my listing of this information, then if I want my 33rd term, that means I'm going to write it with the A standing for whatever the value of that term is, with the subscript 33, letting everybody know that it's the 33rd number in the list. And then it would be A1 plus n minus 1 times D, and we'll kind of figure out what all that stuff would be then. All right, so I have a first term. My A1 in this situation, my first term in the sequence, is -8. My n is 33, and then my common difference we figured out was 7. Now, in order to figure out this 33rd term, then, instead of writing all 33 terms, I'm going to jump ahead and figure out all of those common differences at once. So 33 minus 1 is 32 times 7. I know you can do the arithmetic, but what I want you to figure out or understand for yourself is what this represents. 32 times 7 would be all 32 of those common differences then at once. Instead of you doing add 7, add 7, add 7, add 7, add 7, 32 times, we're doing it all at once. 32 sevens, boom, what's that final total amount? So when we put it all together, 32 sevens is 224. So 224 represents all of the common differences you need total to get to the 33rd term. So then we end up with our 216. Now we're going to talk a lot about reasonableness here when we do these. If this seems like a reasonable number for the 33rd term, we're starting at a -8. We are increasing. We are growing. I know that because my D is +7. The slope is positive. So we definitely should end up with an answer larger if I have a positive slope and I'm going forward in that sequence. So what you're doing, this common sense arithmetic here, is that 32 times 7. You're putting all the common differences together. All right, well, let's go the other way. What if instead I know where I end up, I know the end of my sequence, I don't know where I started. What was the beginning number? Where was that first value in that list? So I want you to find the first term. That's finding the A1. not the steak sauce. Okay, so what's n in this one? Can you tell by the information I gave you? So I said A24 is 58. So how many terms would there be in this list? Well, it's whatever that last term subscript is. So that's the 24. It's my ending term. So the total number in my list would be 24. And they told you the common difference, you know where you're ending. So if you're going to work backwards and find the first term, how many common differences would that be to work backwards? 23, right? So you don't need one for that term you start with. So let's see if that matches up when we do our arithmetic. So I'm going to go ahead and write it in general terms first. My ending term would be the 24th. My initial starting term would be A1. And then we have our n minus 1 times d. So I know where I'm ending up. Now take a look at how I write this. The 24th term is 58. A lot of people get kind of confused, and when they say the 24th term, then they just put a 24 for the term. That's the where it is in the list, not what the number it is itself. So when I say the 24th term, I mean that's the 24th thing in the line, but what it's equal to, its value, is 58. So just be clear on which number that is. We're solving for A1. We don't know what that is. 24 is n. My common difference is 5. Okay, so that means I'm going to have 23 of these common differences. Oops, should be a plus. To get back to this first term. Now let's think about this. The slope in your situation here is a positive 5. So if we are starting at the end of the line, how are you going to work backwards to figure out what the first term is? Well, if you're using the brute force method, you'd start at 58 and you would start subtracting 5, and you would keep subtracting 5 until you got to the first term, which means you would end up subtracting 5 23 times. And take a look and see what you're going to do here. You're doing 23 times 5, which is 115. And look at what you have to do to solve this equation. You're going to subtract that 115 on both sides. So it's like you're subtracting all of those common differences, all 25 of those, or 23 of those common differences of 5, and you're going to end up at negative 57. So if you're going to do the arithmetic just common sense yourself, you would have subtracted 5 that many times as well. It's the same thing. Now think about this. Does it make sense that your A1 is so much smaller than the A24? Well, the slope is positive. That means if you're starting at A1 and going forward, you would be adding 5, and your answer for A24 is positive, so it would have to be bigger, right? If it's a positive slope, if you're starting at negative 57, we'd be going up to positive 58. So that's a reasonable number to get. So just think about, am I going forward or backwards, and what's my slope? Is that even a reasonable number to get? All right, so let's finish up with a couple last examples here of kind of taking this a little bit further. So it says find the number of terms in a sequence whose first term is 10. So find the number of terms. You're looking for n. So I know everything else. I'm trying to figure out how many terms are in my list. So I know where I'm starting, I know where I'm ending, but I have no idea how many terms that is from start to finish. So they're telling me my last term is negative 44, my first term is 10, I don't know what n is, and my common difference is negative 2. Now without even telling me that, if you would have looked at your last term and your first term, if you're starting at 10 and you're ending up at negative 44, so starting at 10, ending up at negative 44, what kind of slope is that line going to have? Well, it's going to have to be negative, right? Because you're starting at positive 10 and you're going to negative 44. You're going down. So that's why this is a negative 2. We have to have a negative slope to make that happen. Well, you have enough information to solve. Let's take a look and see. Just do the arithmetic. Be careful with your signs when you distribute, so you want to be careful. Put your like terms together, and we're going to subtract the 12. So we get negative 56 equals negative 2n, so n is 28. Double check your arithmetic, make sure you're good. Now, is that a reasonable number to have? Can 28 be a number of terms? Well, sure, I could have 28 people in a line or 28 numbers in a list, no problem. What kind of number could n not be? Well, sure can't be negative, right? Negative number of terms, what does that mean? Number of terms should be a positive value, and it has to be whole number. I don't want to be term 1.576, right? What does that mean? You're either term 1 or you're term 2 or you're term 3, you're term 4. You're whole numbers. So n has to always be a whole number of values. So if you don't get a whole number, Something's wrong, so you got to figure out what's going on there. Okay, so last one. This is a great question, so we're going to have to think a little bit on this one. There's lots of different ways to do it too. I'm giving you term 3 and term 17. Those are not consecutive terms in your list. They're not right next to each other. So the bummer of it is you can't really obviously tell what that common difference is, which is what we need to know to be able to do the pattern. And it's the 10th term that I'm asking you to find. So it's kind of a multi-step thing here. Our first quest, before we can figure out the 10th term, which is ultimately the question, we need to figure out the pattern is. What is this doing? So we need to figure out how we're getting from term 3 to term 17. So when people do sort of the common sense arithmetic, think about what you could do to figure out how far apart those are and how many common differences you'd have between them. So what a lot of people end up doing is they say, okay, well, negative 12 and 37, how far apart are they? Well, it looks like they're 49 apart. And then they figure out how many common differences that would have to be. So from 17 to 3, how many common differences? I think that would be 14. Oops. And then they can kind of work backwards and figure out what that arithmetic would look like. And we can figure out our common difference then. So if you take the whole distance between them and divide by how many common differences, we could figure out what one common difference is. So I think when people do the common sense, they end up doing the same arithmetic that I'm going to be doing if I use the formula. So if you're thinking of this common sense, good for you. That's what works. You're doing exactly what this is. Here's the kind of the piece you need to think of. Think of the A3 as like your initial term, the starting term, and that A17 is the final term. The thing that causes people issue here is they say, well, I don't have an A1. I can't do this. I don't have A1 the first term. And the response to that is, you know what? You don't need an A1. You just need a term that's before another one. So you need a starting term and an ending term. There's nothing super specific about where you start and where you end as long as you have one of each. So I can use A3 as my starting term and A17 as my ending term, and that's totally fine. I just have to make sure that I adjust the length of that sequence then. It's not going to be 17 terms long because I'm not starting at term number 1. So just be careful. So you can have an initial and a final just so long as one's before the other. You don't have to necessarily have an A1. So that arithmetic that we ended up thinking about before, think about what we did earlier. Watch what happens now when we do the arithmetic with the formula. So I'm starting with term 3, which is the 37. My ending term is the 17th term, which is negative 12. Notice I'm putting what the term is equal to. So the subscripts are just what number it is in the list. We need to figure out the n, and we're solving for the d. All right, let's talk about the n. If you're going from the 3rd term to the 17th term, we need to figure out how many terms that is. So I'm going to do a tally. If you were watching me, I'd be putting up my fingers, and I need somebody else to help me. So let's count the total number of terms. So we have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 15 terms. Now, think about what we did in our arithmetic before. There would be 14 of those common differences, but there's 15 terms. You have to include term 3 and term 17 when you make that count. So there's actually 15 terms in that list, but if you just subtract 17 minus 3, that's how many common differences you're going to need. There's only going to be 14 of them. You don't need a common difference for that first term, but there are, in fact, 15 terms there. All right, so take a look at the arithmetic then that you end up doing. So we'd have 14 common differences. So what are we doing here? Subtracting 37 is figuring out the distance between term 17 and term 3, and that's negative 49. We drop 49 between those, right? You're starting at 37, ending at negative 12. We dropped 49. And then we're going to divide by the number of common differences, or the number of times we have to split that up, and we end up getting negative 3.5. So think about if that's a reasonable number. It definitely has to be going down, so we know it's negative because we're starting with a bigger number. And it's not a whole number, and they don't all have to be whole numbers. So negative 3.5 is how much each time would be dropped to get to the next value. Okay, now we actually haven't answered the question yet. Remember, ultimately the question was, what is A10? That's what we're trying to figure out. So let's see if we can go back now that we know the pattern and figure out A10. Again, tons of different ways to do this, but let's think of it this way. So I could say that A10 then is the term I'm looking for. I don't have an A1 still. Like I haven't figured out A1, but again, I don't need an A1. I just need a term that's an initial, a starting term. So couldn't A3 serve that function? Couldn't that be my starting term? Well, it's before 10, so it's totally fine. Again, I just have to adjust the length of that sequence. So I have to change my n. Another way you could do it is you could say A17 is your last term and A10 is your first one, and you could solve it that way too, because then you're just solving for the initial term. A10 could be the initial if A17 is your final. That's another option. I think arithmetic-wise, it might be easier to do the first. Some people just started doing the arithmetic, doing the negative 3.5 and moved in the sequence, and you could do it the brute force method as well. So you have so many options. I'm going to try it this way though. So the 10th term would be my third term, plus n minus 1 times, oops, I'm going to need some more room here, my negative 3.5. I'm going to get a little bit more room so I can spread this out here. So 37 plus, we got to figure out what our n is, times our negative 3.5. All right, so from term 3 to term 10, how many terms would that be? From term 3 to term 10. So 3, 4, 5, 6, 7, 8, 9, 10. 8 terms total. Now that means there's 7 common differences. If you're just subtracting the two numbers, you're figuring out how many common differences you need. If you're including the first term, that means there are 8 altogether. So 37 plus 7 times negative 3.5. So you're going to have that 7 of the 3.5 common differences all at once. So we're jumping right to the 10th term. All right, and I think that's 12.5 if I'm doing my arithmetic correctly there. Now that's kind of weird. Why did my answer end up to be a decimal? My 10th term was a decimal, but the two I gave you were integers. They were whole numbers. Think about what your common difference is. It's a decimal, it's a half, 3.5. So that means every other term should be a decimal, right? So the two that I gave you, why are they integers? Oh, those are the odd terms. That means all the evens will be the halves then in between. So some common sense really plays a big part in this and being able to decide what kind of terms seem reasonable. So we're talking about arithmetic sequences. How do you get from one term to the next and use that relationship?